So the first thing you need to understand about substitution is it's swapping out things of equal value. So if I were to give you a dollar bill and you gave me four quarters, they look completely different. It's a different number of each thing. They're made out of, one's out of paper and and the other ones are out of metal. But because they're equivalent in value, the four quarters can replace the $1. That's kind of what we're doing with this substitution method. X has the same value as 7. So where I see x in the second equation, I can take it out and substitute 7 in its place. Now for some students, doing the boxes helps, because one thing I'm going to notice on this second equation, everything outside of that box where the x is going to come down. So the 2, the plus y, the equals 5 comes down. The x, however, and do this inside parentheses, is replaced with 7. Now I solve this equation to find my y value. So 14 plus y equals 5. When I subtract 14 from both sides of the equation, I get, 14 and not 4, y equals negative 9. Remember, what we're finding is if we graphed these two lines, x equals 7 is a vertical line. If we graph these two lines, what's their point of intersection? Well, they intersect at the point where x is 7, because they already gave that to me, and y is negative 9. Don't forget to write your answer, which is an ordered pair, unless it's a no solution or infinitely many solutions problem. The second one, the variable that's all by itself, is x again, and it has a value of 2y. So where I see x in the other equation, I'm going to remove it and put the 2y in its place. Everything outside of this box, the 2, I'm going to put parentheses in to substitute into, the plus 8y, and the equals 1 comes down. But the x is going to be replaced with 2y. Now I'm going to solve this. 2 times 2y is 4y. Bring down my plus 8y equals 1. The 4y plus 8y are on the same side of the equation, so I'm just going to combine them exactly the way they look. 4y plus 8y is 12y equals 1. Then I would divide both sides by 12 to solve for y. If you punch 1 divided by 12 in your calculator, you're going to get kind of a nasty decimal, so we're just going to leave it as 1/12. So I know my final answer, the y value is 1/12, but I have to go and find x. I could substitute 1/12 in place of y in either one of these equations. I think this one is the easiest one. X equals 2 times y is 1/12. 2 times 1/12 is 1/6. So x equals 1/6. So 1/6 for x, 1/12 for y. Make sure you write them in the correct order inside your parentheses. You can check this in your calculator. Check it with the equation that you didn't just use. We kind of used the easier equation to find x over here. We would have to check it in this one by 2 times 1/6 in place of x, plus 8 times 1/12 in place of y. Plug that in your calculator and make sure it really does equal 1. It does, so we're good. Make sure that you've checked it in both equations. You've sort of checked it in this second equation because you used it to find x. You have to then check it in the other equation, just like we did in Learning Target 1. So, the variable in this case that's all by itself is y, not x, and y has a value of 5 minus x. So where I see y in the second equation, I'm going to remove it and substitute 5 minus x in its place. So 1 equals 4x plus 3 times, don't forget to substitute inside parentheses, the y is replaced with 5 minus x because they are of equal value. I'm going to have to do some distributive property here. So 1 equals 4x plus 15 minus 3x. Now the 4x and the minus 3x are on the same side of the equation. So I get 1 equals 4x minus 3x is just 1x. Bring down my plus 15. And then I would subtract 15 from both sides of the equation to solve for x. So negative 14 equals x. I don't need to reverse that and write it as x equals negative 14 because it's not a final answer. But I know my final answer, the point has x is negative 14. Y, then, is 5 minus my negative 14 that I just found. And Plug that in my calculator. 5 minus negative 14 is 19. So I think my point is the point negative 14 for x and positive 19 for y. If I'm going to check it, just use this first equation here, check it in the second equation. Does 1 really equal 4 times negative 14 plus 3 times negative 19? Sorry, positive 19. Plug this into your calculator, and it really does equal 1, so it checks. Excuse me. This is one that kind of throws people off, but if you think about what you're doing, y has a value of 1.5x. So where I see y in the second equation, I'm going to replace it with 1.5x. So I end up with 1.5x equals the rest of this equation, 12 minus 2.5x. I'm going to add 2.5x to both sides of the equation to get the variable over on the left with the other variable. And I end up with 4x equals 12. So then when I divide both sides by 4, x equals 3. As soon as I know part of my answer, I'm going to go start. 3 should go first because it's x. I can plug 3 into either one of these equations to solve for y. I'm going to plug it into the first one. Y equals 1.5 times 3. So y equals 4.5. And then to check to make sure my answer is correct, I'm not going to write it out this time, but I would go into this equation and I'd do 12 minus 2.5 times 3, because x is 3, equals, and make sure it equals 4.5, because y is 4.5. We had some special cases where when we graphed the lines, it was either the same line or it was parallel lines. So we didn't end up with an answer that was an ordered pair. We had either a no solution or infinitely many solutions. This is what's going to happen on these kinds of problems when you see that. Y has a value of 3x minus 7. So I'm going to substitute that for y in the second equation. 12x minus 4 times, in parentheses, the y is replaced with 3x minus 7, and then bring down my equals 10. I'm going to distribute negative 4 to 3x and negative 4 to negative 7, sorry. So 12x, negative 4 times 3x is going to make this a minus 12x. Negative 4 times negative 7 is going to make this a plus 28 equals 10. On the same side of the equation, I have 12x minus 12x, which is 0. So there's no x. It's totally dropped out, and the equation simplifies to 28 equals 10. I can't solve for my variable because I have no variable left. And here's my thought process. 28 never equals 10. So this is no solution. It's never going to work. Nothing is ever, no value of x that I put in is ever going to make those two sides of the equation equal in both cases. Now this one, x by itself, has a value of 4y plus 3. So I'm going to go to where x is in the second equation, and I'm going to replace it with 4y plus 3. I'm going to substitute 4y plus 3 in its place. So 2 times instead of x, 4y plus 3 minus 8y equals 6. When I distribute, I end up with 8y plus 6, bring down my minus 8y and my equals 6. On the same side of the equation, 8y minus 8y. So that's 0. And I get positive 6 equals positive 6. Make sure you're paying attention to the signs. If this was a minus 6, then it'd be negative 6 equals positive 6, which is never going to be equal, so it'd be no solution. But 6, positive 6, always equals positive 6, so this is infinitely, which is infinitely, many solutions. Now, please pause the video and go and do that last problem for yourself first, and then restart the video and come back and check it with what I'm going to do. So I look at this and I see y equals 4x minus 2. So I go to the second equation, and where I see y, everything else gets copied down. It's parentheses where the y was. y is going to be replaced with 4x minus 2. When I distribute, I get 3x plus 8x minus 4 equals 18. 3x plus 8x on the same side is 11x minus 4 equals 18. When I add 4 to both sides of the equation, I get 11x equals 22. So then when I divide by 11, x equals 2. I can start my answer. It's the ordered pair 2 something. I'm going to take this first equation because it looks easiest. Y equals 4 times 2, because x is 2, minus 2, which is 8 minus 2, so y equals 6. To check my answer, I would go and I would take this equation, the equation I didn't just use, 3 times 2 for x plus 2 times 6 for y, plug that in my calculator, and make sure it equals 18. It does, so it checks. My answer is the ordered pair 2, 6.